Good morning to Madam Shuhada. For CGE526 group assignment, our group has chosen the topic of hybrid reservoir. And this is our group members, which consist of Irene Nurauda, Muhammad Zulkhairi, Mio is Daniel, and me myself, Josephine Jelenda. First, I will be presenting our introduction. Hybrid reservoirs such as shale plus tide formations is a type of unconventional hydrocarbon. Low porosity and permeability in this reservoir make extractions more challenging, and rather than the usual vertical well drilling method, extractions are often done using directional drilling and hydraulic fracturing. Hybrid reservoir is a reservoir system that has both the matrix and fracture components, exhibiting what's known as dual porosity behavior, where the low permeability matrix is commonly used for storage and the fracture provide high permeability pathways for fluid flow. One example of hybrid reservoir is shale plus tide formations. Shales have low permeability and are used for storage. Meanwhile, tide formations such as tide sandstones or carbonates can be used as additional storage, and they have high brittleness, which is better for fracturing.
Next, we will go to geology, geological setting, and formation mechanism. For geological setting, hybrid reservoirs are commonly found in unconventional petroleum systems where both organic-rich shale and low permeability tide rock, such as sandstone and carbonate, coexist. This geological setting typically develop in deep marine or foreland basin where fine-grained sediment and organic matter settle under low energy enoxic condition. Over geological time, this basin experiences cycle of sedimentation that result in alternating layers of shale and tide reservoir rock. In many cases, these formations are influenced by tectonic force such as compression and uplift, which further modify the subsurface structure and enhance fracturing. This leads to complex stratigraphic and structural settings that favor the development of hybrid reservoirs with significant variability in porosity and permeability. For the formation mechanism, the formation of hybrid reservoir involves a combination of depositional, thermal, and diagenetic process. Initially, organic-rich shale are deposited in quiet, oxygen-deprived environment where high concentration of organic material are preserved. Simultaneously or subsequently, tighter sandstone or carbonate rock are laid down in more energetic environment such as deltaic system or reef platform. As burial depth increase, both rock type undergo compaction and cementation, which reduce pore space and permeability in the tide formation. The shale layers, rich in corrosion, begin to generate hydrocarbon as they reach thermal maturity. These hydrocarbons are either retained within the shale, which act as both a source and a reservoir, or migrate into the nearby tide rock. Migration within hybrid system. Migration within hybrid system tend to occur over short distance due to the close vertical proximity of the shell and tight reservoir layers. Natural fracture created by tectonic stress, as well as artificial stimulation method like hydraulic fracturing, play a key role in enhancing fluid flow. This fracture connect otherwise isolate pore space and allow hydrocarbon to move from the shell matrix into the tighter reservoir units. This interaction results in a dual porosity and dual permeability system, where production relies not only on the matrix properties but also on the connectivity and extent of the fracture network. The interplay between these two storage and flow systems define the unique behavior and challenge of hybrid reservoir in the context of petroleum exploration and production.
So now, me, Irene Rauda Doraza, will be explaining about the geomechanical properties of hybrid reservoir, which are made up of combination of shale and tight sandstone. These properties are very important because they influence how oil and gas can be extracted from the rock. Let's start with the first one, which is shear strength. This is the rock's ability to resist breaking when force is applied. In hybrid reservoir, shale usually has low shear strength and behaves in a ductile or flexible way, meaning it bends or deforms rather than cracking. So the tight stone is the opposite. It has high shear strength and tends to break with brittle manner. Because both rock types are present together, predicting where and how fractures will occur becomes more difficult. This mixed behavior and complexity to designing safe and effective drilling operation. Next, we're going to move to the second one, which is permeability. This refers to how easily fluids can move through the rock. Both shale and tight sandstone naturally have a very low permeability, which means oil and gas cannot flow easily. However, microfracture and hydraulic fracturing can help improve flow by creating pathways. The effectiveness of these fractures depend a lot on the brittleness and stress condition of the rock. Without enough fracture connectivity, the hydrocarbons will stay trapped. So, for the last one, which is deformation behavior. The deformation behavior refers to how the rock responds to stress, like pressure from drilling and production. In hybrid reservoir, shales tends to deform or bend, while tight sand is more likely to crack. These different responses to stress affect how fracture networks develop, which plays a big role in hydrocarbon movement. If the fracture don't form properly or close up, production will be very low.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mio Izdini bin Mio Anwar, and I will talk about case study, production and field environment. Okay, the place that we observe for the hybrid reservoir is located at the South Texas, and what I talk about is the Eagle Ford Shale. The Eagle Ford Shale is a significant hydrocarbon production geological formation located at South Texas, and is known for its rich deposit of both oil and natural gas. Its major player in U.S. energy landscape, with the operation involving advanced drilling and the completion technique to extract the resource. Composed of organic rich shale in the bed with tight carbonate like limestone and dolomite, and it's at asphalt source like rock and reservoir, storing the hydrocarbon in both the low permeability shale matrix and in natural fracture or hydraulic fracturing. It demonstrates dual porosity behavior and require the advanced stimulation technique due to extremely low matrix permeability. The breakdown is total organic content, and we can call it TOC, and the regional stress regime strongly influence production success. And this is the picture of Eagle Ford shale location. For the field development, the margin of the rock is notably bright, making it a prime target for oil and gas extraction throughout the hydraulic fracture, or we can call it fracking, a process in which rock is smashed with a high pressure mix of water, sand and chemical to release the smaller bucket of oil and gas inside. And as we can see at the next picture is the fracking machine for dealing the oil and gas. The fracking has become significantly more effective since the innovation of horizontal drilling. Well can be moved horizontal to shale bed. Hydraulic fracturing is one of a primary way to manufacture retrieve natural gas today, and it used in 9 out of 10 of the contained natural gas, while the Eagle Ford shale yield both wet and dry gas. Okay, this is the fracking machine at the Eagle Ford that extract the wet and dry gas, and as we can see, it have a horizontal drilling for both picture, and the process is like I said before, to extract the wet and dry gas. And when do the process, it has the water, sand and chemical injection into well to extract it. Okay, and this is the stratigraphy of the process at Eagle Ford, and as you can see, it has a signal or manufacturing for the process will do the drilling to get the wet and dry gas.
Next, for the challenges and implications of exploring hybrid reservoir. The first challenge is low porosity and permeability. Porosity and permeability in this reservoir are significantly lower than conventional reservoir, so extractions are difficult due to negligible natural flow of hydrocarbons to the wellbore without stimulation. So implications are requiring modern technology such as hydraulic fracturing to create artificial fractures. This process involves the injection of high-pressure liquid into a rock formation to create fractures. The second challenge is high development cost. Exploring this reservoir requires multi-stage hydraulic fracturing and advanced tools such as 3D seismic imaging and reservoir modeling software. The implications are higher upfront capital investment and higher economic risk compared to conventional reservoirs. And the last challenge is environmental and health concerns. Construction of infrastructure like the pipelines and roads to transport the produced oil and gas can change the landscape. Waste from hydraulic fracturing contains dangerous pollutants that are often associated with negative health effects. So the implications are delays and bans due to regulations and also increase in compliance and monitoring.
Okay, the importance of the hybrid reservoir at this day and the future. The hybrid reservoirs are increasingly important in today's petroleum industry because they enable more efficient production of hydrocarbon from complex formation to extract the oil and gas, especially in mature well area with existing the infrastructure can be reducing the cost and extending the field life. Got a multidisciplinary approach, particularly of geomechanics. Operation can design better for more effective hydraulic fracturing strategy to increasing the production rate, and also can recovery and minimize the risks such as well fail or the uncontrolled fracture growth. And from the societal perspective, hybrid reservoir contribute to energy security while support the global transition to renewable energy, with the advanced technology, environment impact can be reduced, such as they play a key role in the balancing the current energy need with a more suitable future. And that's all from us. Thank you.